Okay, as far as free body diagrams go, these should be some of them are really, really easy and some of them are a little bit trickier. The more examples I walk you guys through, the easier that it will get. It's very easy to see me do it and be like, oh yeah, that makes sense. It's much harder if you're actually trying it on your own. Lucky for you guys, you're probably not going to have to do that. So just understanding why they're the way that they are is kind of what you need to do. So for each problem that we have where we have to draw the free body diagram, I'm always going to start out trying to go through the keywords with you, and then from that determine if it's balanced or unbalanced, because that's going to tell us the size of the arrows and if they're the same length or different lengths. So we'll start out with easy ones, and then they're going to get a little bit more challenging as we go. So if we have a book at rest on a table, a free body diagram would look like this. So all we have is a book resting on a table. Keywords right here would simply be that book is at rest, which means that it is motionless, which means as far as forces go, the net force is 0 and it would be balanced. That doesn't mean that there's no forces acting on it. That just means that those forces are balancing out, which is why it's at rest. So we always are going to draw the box instead of an actual book. Gravity is pretty much always going to be a force that you're going to be dealing with, and it's always going down or center of the earth. And the reason that the book is at rest is the force that's counteracting it is going to be the normal force. So your free body diagram would look like this, where we have the arrow for gravity going down, and in the opposite direction, we have that normal force going upward. Notice that those arrows are the same length. They have the same magnitude, which is why it is balanced and at rest. Next example, a girl is suspended motionless from a bar which hangs from the ceiling by 2 ropes. Free body diagram looks like this. Keywords here are that the girl is suspended motionless. Again, not moving, which makes this another example that it's going to be balanced. So we know that our arrows are going to end up being balanced out. We're going to have the force of gravity again going downward in the opposite direction because she's hanging motionless. That's technically the force of tension is how we want to be labeling that. So you see 2 arrows going upward, and I have 2 arrows, not 1, because it says that she's hanging by 2 ropes. So there's going to be 2 forces right there. If I added up the length of the 2 tension arrows, that's going to equal the force of gravity arrow, or it's supposed to, again, because it is balanced. That's what it's supposed to look like. Okay, next we have an egg is free falling from a nest in a tree. We are neglecting air resistance, which means in this specific scenario, we're just not counting air resistance. We're pretending that it doesn't necessarily even exist. Keyword here is free falling. If you know what the word free falling means in the term of science, it really simply means the only force acting on it is gravity, which is going to make our drawing pretty easy. So as far as our forces, it is unbalanced, which means that it is accelerating. So my free body diagram would simply look like this. The net force is greater than 0, which is why it's unbalanced, and that's why that it's accelerating. So if it was balanced, those 2 arrows would equal out, but we know it tells us we don't have any air resistance, which would be an arrow that's right there. So our free body diagram for free fall looks exactly like this. Only force acting on that object would be gravity. Next, we have a flying squirrel is gliding. It's telling us right here that there's no wing flaps from a tree to the ground at a constant velocity. So our keywords here would be constant velocity. If an object is traveling at a constant velocity, that right there is balanced. That's a lot of people get really confused with that. They think balance means not moving. It is either not moving or traveling at a constant speed, which means balance means that those forces are really going to be equal. So we know that it is our squirrel, gravity is going to be acting upon our squirrel, and also air resistance is going to be acting upon our squirrel. Air resistance is really the friction of air, in other words. So it will very often, if something is falling and not like a normal force going up, it's going to be air resistance that's going to be going in that opposite direction. So again, arrows are equal because it is a balanced force.